Okay, if we find all the solutions for 2 sine squared x minus 1 is equal to 0, and now we are actually in an interval. X is going to be between 0 degrees and 360 degrees. Okay, so we're going to have 2 sine squared of x minus 1 is equal to 0. First thing I'm going to do is I'm going to add 1 to both sides because I'm trying to solve for just sine. So 2 sine squared of x is equal to positive 1. Then I'm going to divide both sides by 2. So sine squared x is 1/2. Okay, to get rid of the squared, I'm going to square root, and anytime you put the square root, you also need to put a plus or minus sign, which it doesn't matter if I put it here because this 2 and the square root will cancel each other out, and I'm left with sine of x is equal to plus or minus the square root of 1/2, which we can break this apart. So plus or minus the square root of 1 over the square root of 2, which that would be plus or minus 1 over the square root of 2. Okay, so now I have sine is positive and sine is negative. So where is sine positive? Well, that's the first and the second quadrant. And then where is sine negative? Well, that's the third and the fourth quadrant. So we will have 4 different triangles here. Okay, so I know these are going to be 45 because this is going to be y over r. So y is going to be 1. So there'll be positive 1 here. That's for this positive. There'll be negative 1 here for this negative. And then your radius will be the square root of 2 for all of them. Which means if I have a square root of 2 and a 1, that means that this is 1, this over here is negative 1. Straight across from my 1's are 45 degrees. And that's just using your special triangles. Okay? So then you want to get your angles in standard position, which this first one is already in standard position, so you've got an answer of 45. Okay, to get the second one, we would do 180 minus 45, and that would give us 135. For the angle in the third quadrant, we would have 180 plus 45, and that would give us 225. And then for the fourth quadrant, we would have 360 minus 45, and that would give us 315. Okay, so I have answers here, 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 and here. But remember, we are working within an interval. So if I take this 45 and I add 360, well, that's going to give me something outside of 360. If I take 135 and add 360, it'll give me something outside of 360. Because it's saying that no angles can go below 0, no angles can go above 360. If I add 360 to any of these angles, it will give me an angle that is beyond 360. Okay, so my x values are 45, 135, 225, and 315. Those are the only angles that will work for this formula within this interval. So those are your 4 answers right there. Now, anytime we are dealing with a reciprocal and we're trying to find all the solutions, there's only one more step that we need to do. So if we got cosecant of x is equal to negative 2, well, the only thing I need to do is put a 1 over both of them. Because 1 over cosecant, well, that's the same thing as sine of x. Okay, so sine of x is equal to negative 1/2. Okay, so anytime you've got the reciprocal, so cosecant, cotangent, or secant, put a 1 over both sides, because whatever you do to one, you've got to do to the other side for them to stay equal. And then just use your reciprocal identities. Now our range is 0 degrees to 720. Okay, we just had this problem right here. We looked at it right. Let's see, where was it? Right here. Okay, so this was our solution if we didn't have an interval. Okay, so let me write that over here. So the solution set to this was x such that x is equal to 210 plus 360k, or x is equal to 330 plus 360k. What we did was we asked, okay, where is sine negative? And sine is negative in the third and the fourth quadrant. This is saying that this is y over r. Our y will get the negative because r will never be negative. So -1, -1. This is a 2. This is a 2. That's a square root of 3. That's a negative square root of 3. Okay, opposite are 1s. These are 30s. We want the angle in standard position, so we did 180 plus 30. That gave us the 210. And then 360 minus the 30. That gave us the 330. So we have an answer here and here. Okay, so this is not going to be my final answer right here because I'm looking for, yeah, all solutions, but within this interval right here. If I got rid of this interval right here, then yes, this would be our final answer. But since I have an interval, I will have actual angles for my final answer. Okay, so if I take 210 and if I add 360 to it, so if we take 210 plus 360, okay, well that's going to give us 570, which that is still within this range. And if I do 210 plus 360 twice, then that's going to give me 930. Okay, this angle is outside of this range, so that is not going to work. Then if we take 330 plus 360 just one time, that would give us 690, which this angle is within that range, so that's fine. And then if I take 330 and if I add 360 twice, that's going to give me 1050 degrees, which that is outside of 270, so that angle won't work. So the only angles that work are the 210, the 330, the 570, and the 690. So x equals 210 and 330 and 570 and 690. These are all the angles that will satisfy this equation within this interval. So far we've been looking at trig equations that have just an x right here, but let me show you what to do if the number right in front of x is anything other than 1. So we would do the same thing. Cosine of 2x is equal to 1/2. The next thing to ask is, okay, well, where is cosine positive? Cosine will be positive in the first, so all students take calculus, and the fourth quadrant. This is saying this is x over r, so r is 2, and x is 1, which means this is square root of 3, and negative square root of 3, which means these angles are 60 degrees. Okay, so I need standard position, so I've got it here in the first quadrant. That's just 60. To get standard position for the angle in the fourth quadrant, you would take 360 minus 60, which would give 300. Okay, so we got two answers, one here and one here. To get back to this answer right here, you would keep adding 360, same thing here. Notice I don't have an interval. So I have x such that, and actually this is not x anymore, this is 2x, because whatever is inside here, that's when it's going to go here and here. Okay. Oops, let me sure rewrite it. So 2x such that 2x is equal to, all right, 60 plus 360k, or 2x is equal to 300 plus 360k. And then what we're going to do is we're going to divide every number by 2. So it's just an x. Go ahead and divide them by 2. So this would be x such that x is equal to, okay, half of 60 is 30, plus half of 360 is 180k, or, okay, x is equal to half of 300 is 150, plus half of 360 is 180k. This would be your final answer for this equation right here. Okay, we are going to find all the solutions for 2 sine squared x minus 3 sine x plus 1 is equal to 0, and it's going to be in an interval from 0 degrees to 360. So we're going to take 2 sine squared of x minus 3 sine of x plus 1 is equal to 0. Okay, what I could use here, you could change, if the signs are messing you up, change it to x's for a minute. This would be 2x squared minus 3x plus 1. Okay, if we look at this, I can factor this into 2x minus 1 times x minus 1 gives me 0. 2x times x, that would give me the 2x squared. 2x 1, that'd be the negative 2x. Negative 1 times x, that'd be negative x. That gives me negative 3x right here. Negative times a negative, positive 1. Okay. Well, I just substituted a sine for an x. So you could have written this as 2 sine of x minus 1 times sine of x minus 1 is equal to 0. Okay, so I've got two things multiplied together to give me 0. I can break both of them apart, set them both equal to 0, and then solve. So this would be 2 sine of x. Move that 1 over, becomes positive. Divide both sides by 2, so 1/2. Here all I have to do is move 1 over, so that would give me 1. Okay, so for sine is equal to 1, I'm going to use the unit circle for that. Okay, so this would be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. I'm looking, since it's sine, I'm looking at the second number. Okay, and the second number needs to be 1, which it is right here, and that is 90 degrees. Okay, so my x for this would be 90 degrees. And then for this 1/2, I'm asking, well, where is sine positive? Quadrant 1 and 2.